Alright, today we're going to look at quadratic inequalities. Okay, let's start off with the first example. Find the range of values of x for which x plus 1 times x minus 3 is bigger than or equals to 0. Now, by asking this question, we can also interpret it as let y equals to x plus 1 times x minus 3. For what values of x would make y bigger than or equals to 0? Alright, so I introduce a y here, okay, to explain this quadratic inequality. Alright, so this is a quadratic inequality simply because the left hand side expression here is quadratic if we expand it out. Right, so this quadratic inequality actually has factors x plus 1 and x minus 3. Alright, to find the values of x which would make y to be bigger than or equals to 0, let's test some values of x to see whether they satisfy the inequality. So for example, let's try x equals to negative 1. So when x equals to negative 1, okay, negative 1 plus 1 is 0. 0 times anything is 0. So y equals to 0. Alright. So when y is 0, y is bigger than or equals to 0. So it does satisfy the inequality. Similarly, if I let x to be equals to 3, 3 minus 3 is 0, so y equals to 0. And again, it satisfies the inequality. Now, this shouldn't surprise us since x plus 1 times x minus 3 equals to 0 gives us roots x equals to negative 1 or 3. Let us now test other values of x. Let's try some value of x less than negative 1. Okay, for instance, let x to be negative 2. So when x equals to negative 2, y is equals to negative 2 plus 1 times negative 2 minus 3. So this gives me 5. Y equals to 5. Since 5 is bigger than or equals to 0, it satisfies the inequality. Okay, let's try a value between negative 1 and 3. Okay, so for example, let's try x equals to 0. Right, x equals to 0. So when I try x equals to 0, y equals to 0 plus 1 times 0 minus 3. So this gives me negative 3. And negative 3 is less than 0. Alright, so it does not satisfy the inequality and we have to rule that out. Let's try the last case, okay, where x is bigger than 3. So for instance, let's try x equals to 4. And when x equals to 4, y equals to 4 plus 1 times 4 minus 3, which gives me 5, which is bigger than or equals to 0. So again, it satisfies the inequality. From this table here, you'll notice that all values of x less than negative 1 will satisfy the inequality. Similarly, values of x bigger than 3 also seem to satisfy the inequality. Now, this shouldn't surprise us, since from the graph of y, okay, we have these two roots. So the graph looks something like this, right? Cutting these 2 points here, negative 1 and 3. Whenever the graph is above the x-axis, the values of y are positive, right? So when x is less than negative 1, okay, the values of y are positive. Similarly, when the values of x are greater than 3, the values of y are also positive. However, when the values of x are between negative 1 and 3, the values of y are negative, since the graph is below the x-axis. So in conclusion, for y to be bigger than or equals to 0, x must be less than or equals to negative 1, or x is bigger than or equals to 3. So this is the final answer, and it concludes this question. So let us summarize the key steps in solving a quadratic inequality. There is no need to draw a table. All you have to do is first find the factors by factorizing the quadratic inequality. Secondly, doing a sketch of the curve and determining which areas are positive for y and which areas are negative for y. And then from there, try to deduce the solution of the inequality. Let us try another example, okay, to consolidate our learning. Okay, in this example, find the range of values of x for which 3x squared is less than x squared minus x plus 3. So first step is to form a quadratic expression. So I'm going to bring everything on the right hand side to the left hand side. So I get 3x squared minus x squared plus x minus 3 is less than 0. So 3x squared minus x squared is 2x squared plus x minus 3 is less than 0. So we have a quadratic expression on the left hand side. In the first example, we already had the factors of the quadratic expression. So what we're going to do now is to try to factorize the left hand side. Okay, we could simply do this using the cross method. So I'm going to break 2x squared into 2x and x, and 3 into 3 and negative 1. So 3 plus negative 2x gives me x. So great. I can factorize this now. Alright, so with this, I'm going to draw the graph of y equals to 2x plus 3, x minus 1. Alright, so this graph will have roots 1 and negative 3 over 2. So it's going to look something like this. So again, in this inequality, I want to find the values of x which satisfies this less than 0. Okay, less than 0. So what are the values of y so that the values of x is the solution? So in the graph here, we see that y is bigger than 0 when x is less than negative 3 over 2. Similarly, when x is bigger than 1, y is also bigger than 0. So, but if x is between negative 3 over 2 and 1, okay, the curve is below the x-axis, which tells us that y is less than 0. Hence, the solution for this inequality is x is between negative 3 over 2 and 1. So this is, in a nutshell, how you solve quadratic inequalities.